Hello guys, we are back with another Leetcode challenge. Let's see the today's challenge, and today's challenge is counting bit. It's a fall into the easy category, but it's a must do question because it's a like question. So let's go into that. What actually question asks? So you have given an integer n, and what's your duty? You have to return the array of ones which have length n plus 1 and corresponding each of I. What's your duty? You have to find the number of once is present in the binary representation of that I. So that's a pretty much about straightforward question. If you don't understand a little bit more, understand this while using example 1. So let's take an example 2. It make more sense. So n is equal to 5. So how many element in my array will be 6 because I have to return length n plus 1, and it's going where it's go. It's starting from 0 to till the end. So starting from the 0, I is equal to 0, and corresponding I is equal to 0, how many set bit is present in the binary representation of this I. So my I is 0 right now, and the number of set bit in that case, you see there is a binary, here is a binary representation, but in this it not any ones. So in that case I'll return 0. In 1 there is only one bit is 1, so I'll return it. For 2, for representing 2 in binary form, we represent like this, and the number of set bit is 1 in that case too, so that one. There's a 3, the binary representation of 3 is 1 1. So how many set bit in that case? 1 and 2, so there is a 2 set bit in the 4, and similarly like that. So that's pretty much about the question. So what you do, you have to count the bits. You have to count the bits, set bits, sorry. You have to count the set bit in every I from 0 to n. So that's your duty, and you have to return in the form of the array. So how can we do that? We can do with it. We can do manually, means every I, for every I call it a function. Let's name it count the set bit. I made a function count the set bit. What my duty? Every 0, for 0, I'm calling my count the set bit. It give me the number of set bit present in that. So that's the one of the approach. And in that case, my time complexity will be how many, the length, the size of the n, means value of the n means n log, sorry, n into the function. My set bit actually count for counting the set bit, I needed a log n space because I'll try to traverse in the form of divided by 2 divided by 2. So it's a, my time complexity will be n log n in that case. So but here is given a follow-up. It's very easy to come up with a solution of runtime n log n, but we have to do it, uh, we have to do a linear time and in a single pass. That's our motto. So our solution will be in linear time complexity. For doing the time linear time complexity, I have a, I see a one pattern here. For you see the same pattern, I'll write some binary forms. This represent actually 8, this represent actually 9, this actually represent 10, and this actually represent 11, and this actually represent 12, this actually represent 13, and this actually represent 14, and this is 15. Okay, let's say if I know about my, what I'm going to do, I'll try to generate my next count set. I try to find out this 10 from my previous data. So how can we do that? Here is notice that the, if I, let's see the pattern from 12 and 13. So 12 have the 2 set bits and 13 have the 2 set bits. If you see the same pattern, 14 have the 2 set bit, 15 also have the same set bit. Why? Because the next and previous have the same set bits. What we are going to do, we have to just at the same time only one set bit changes. Here you see there is a 1 1 1 0. So here you see only one set bit changes. Here is a 1 0 1 1. Here is two set bit. Here is not any changes occur. One, and here is only one set bit is changes. Here is only one set bit is changes. Sorry, not any set bit is changes. Sorry, only one set bit is changes in that case. Here also one set bit is changes. In that case one set bit changes. In that case one set bit is changes. But in the case of whenever I got uh, two power n numbers, means which is which is the which is a power of 2. If any number is power of 2, it makes some violation. But if it's not a power of 2, in that case my I have a data about my previous, I use my previous data and I did 1 only, it give me answer. But I have to just remove my set bit 2. So for doing that, what I'm going to do, so let me check what I'm going to do. I make a vector in which I'm going to store the data about, I'm going to store the data about the set bits, and let mention it is size 2. So n plus 1 size is n plus 1 and initially initialized with 0. And I know about data, I know about my I is equal to 0 contains 0, so no needed to do that. I greater than n colon I plus what's my duty, v. What I'm going to do, I know if my vi is equal to 1. In that case what can I, how can I know about 1 is also a power of 2. If any number is power of 2, what I actually notice, it's a always multiple of 1. It's it contain only one element. So and it's contain only one element, I add it. But and I have to I have a data about, I have to data about the previous one too. So for knowing the previous data, if write it I minus 1, it represents 0. But it in that case let's see here, if you see this 1 and 1, I'll change my set bit, lower set bit I have to change it. So if I low I lowest set bit, the lowest set bit I'm going to unset. So in that case this 1 0 0 converted into 1 0 0 and I did 1 in that case. So there is catch. For doing that, what I'm going to do, I'll have to check it, and I'll do this. It handle all the cases. Like if my I is okay, let me explain what I do here. This I minus 1 actually becomes 0 whenever it encounter with power of 2's. If not, if not, if I is not a power of 2, in that case what it going to do, it unset the set bit, lowest set bit going to change into 0. So it decreases. Whenever it decreases, it reaches to that number where have the like if we are, if we try to find out 14, if we have given n is equal to 14, let's dry run this code again. Let me just complete my code, then dry run it. So we are given n is equal to 14. Let's say we are given n is equal to 14 and corresponding n is equal to 14. What is my bit? This, see, okay, just write it, this. So what we have to, we are, what's my duty, we have to find out this 1100. How many set bit is present? So 1100, what I'm going to do, my duty is that if I've tried, let's put in the formula 110. I have to find out corresponding to 14. V14 equal to 1 plus 14 and 13. 14 and 13. If I take the AND operation into between them, what I got in this, I got a set bit 1 1. Let me write 1 1. I got 1 1, and 0 into 1, 0 and 1 is 0, and 1 and 0 is going to 0. What it actually does, it actually unset this last bit of my previous one. It's unset, and now my number is become my I minus 1 is pointing here 12, and V12 contain the number of set bit is 2. So this Vi, this is going to change into V, this whole stuff we're going to change into the 2, and 2 plus 1 is going to 3, and that's it about our number of one set bit into this 14 is 3. So that's our motto to do that. So let's submit this code, guys, and hopefully it's going to work fine, and it's absolutely accepted. So if you have any doubt, let me know in the comment section. I resolve your doubt as soon as possible. Until then, keep grinding, guys.